outside of 2 standard deviations from average. That's one real quick and easy way of measuring outliers. Anything outside of 2 standard deviations, we term an outlier. Anything outside of 2 standard deviations. Why 2? Why not 1? Why not 3? The rule actually changes. I remember being, as an undergrad, the definition was 3 standard deviations. Well, I shouldn't say the definition was. One definition that I saw was use 3 standard deviations. The problem with 3 standard deviations is it's extraordinarily restrictive for small data sets. That's essentially everything. 3 standard deviations includes every one of your data points. Okay? It works great for large data sets. As a matter of fact, 6 standard deviations, 6 sigma, you may have heard of this. It's a really neat, well, I shouldn't say neat, it's a cost-cutting measure. 6 sigma says anything outside of 6 standard deviations is unusual. And the reason that's used when you're talking about like tech parts, like when you're manufacturing hundreds of millions of little tiny like microconductors and semiconductors and things like that, you don't want those goofy ones with really tight tolerances getting through. So when the tolerance of these parts are extraordinarily small, 6 standard deviations is not as far as it seems, but it is far enough to screw up the behavior of electronic componentry. So we're going to stick with 2, because 2 is what is used in most research, most psych journals, most natural resource journals, most ECE journals. They tend to use 2 standard deviations. So my next question is, do we have any outlier weight guesses? Did anybody guess my weight too high or too low? By the way, on average, I'm about 3 pounds from that, 170. Depending on what time of day, when I last ate, I'm somewhere around 170 to 174, somewhere in that neighborhood. Yeah, sometimes I dip below 170, but not too often. So you guys, on average, targeted me. But now my question is, was the 155 an outlier guess, or was it just a low guess? And was the 185 an outlier guess, or was it just a high guess? An outlier being, in other words, by this definition, is it too high or too low? Are either of those too high or too low? Well, now, we have these summary statistics right here, so we can just say it's 170 plus 7.3 doubled, right? 2 standard deviations means, so we'll do it this way. Too high a guess would be bigger than, so this would be above the mean by 2 standard deviations. So it would be x bar plus 2 s's. So by our numbers, that's 170 plus 2 times 7.3. Does that make sense? See what I'm doing there? So what I'm doing is, we're taking that idea of standard deviation from we talked about before and just looking at the right half of it now. The right half of it. And we'll put the graph back up momentarily and re-look at it 2-dimensionally as well. So this is going to be 170 plus, what is that, 14.6?
Yeah.
So this comes into 184.6 pounds. So any guess above 184.6 pounds would be termed too big. So that's an outlier guess. Again, by this definition of outlier. I'm not saying it's a universally accepted term. I'm saying it's used frequently, right? So is what Congress says. Doesn't mean it's right. It's just used frequently. So anything above 184.6 pounds would be, if you will, too large a guess to be considered usual. This word outliers, it's a beautiful word. It's a beautiful word. But again, part of the discussion I want to start today and continue on Wednesday is to make sure we actually know what the word outlier means. And at it, I know we have an idea of what we think it means. We think it means too big or too small. Basically, what it just means is atypical. That's really all it means. An outlier is an atypical data point. Now, most of the intro stat textbooks deal with this as atypically large or atypically small. But it can also be atypically in the middle. You might remember when I showed you guys data from my Math 95 class where I had the strongly bimodal test results. Atypical were the ones that were actually at average. There were very few of them. They were rated average, and there were very, very few of them. That makes them atypical. So basically outliers are just ones that are different than typical. This this measure, this way here, if you will, this one way, I was going to number this one, I guess. This one way we're talking about is only chopping off the too high and too low. Are there any too low ones? Let's check too low. Were there any too low guesses? So was Liz's guess too low a guess? To be typical. But this would be less than. So we have to go x bar minus 2s. So now we're doing the other side of the standard deviation measure. We got the high end over here. We're going to go the low end over here. I guess I should have done these backwards. Whatever. So that will be 170 minus 2 times 7.3. That's 14.6 again. So that comes out at what, 155.4? Did I do that right in my head?
Yep.
So, by that definition, is Liz's guess too small?
No.
It is, isn't it? Just barely. Because she guessed 155. That's just below 155.4. No, Elena, thank you for saying that. Because I wish I had written these this way. I wrote high on the left side and low on the right side. That's kind of dumb if you think about it. It should be low on the left, high on the right. So essentially, here's why it might be a little bit hard to see. Let me turn the graph back on. And I'm going to put it over here so I don't erase all this beautiful stuff that we just kind of agreed upon. Not that you have to agree with it, but it's just, like I said, it's what is used as measures of unusuality or atypicality. Slide that over here. Okay, so essentially, what we just discovered, here's 170 right here in the middle. So this, I believe the way the TI set this up is 155, 160, 60, 65, 65, 70, 70, 75, 80, 85, 90. No, we started at 155, didn't we? So I bet you this is 150. Let me check my window real quick. No, I was right, it is 155. So here's 155, here's 160. What it ended up doing, I'm going to make this discrete. I'm going to break the law a little bit here as far as what you're seeing on the horizontal. So this is the split between the 155 and the 160s. That is where the second standard deviation stopped, right above it, 155.4. So it stopped right above 155. Just like on the other side, it stopped at 184.6, which is just below the 185. So here's your two standard deviations right here. There are your two standard deviations. That's why this guess down here and that guess up there are considered to be outliers by this definition, because they're too far left and right of that second standard deviation marker up and down. Is that fair? And again, like I said, that's the definition. That is what has been decided, and it works pretty well. What it basically means is, out of every 20 data points you have, on average, one of them is going to be too high or too small, assuming you have bell-shaped data. Assuming you actually have bell-shaped data. Does that make sense? Does that make sense? Fair? So assuming you have bell-shaped data, you're going to get, on average, 1 out of 20 either too high or too small. Now, we just happen to have 2 out of roughly 20 that are too high or too small. But I said on average, 1 out of 20. I've done this experiment in class where I've had no outliers, which means they're all within 2 standard deviations. That happens sometimes too. But if you average all of them together, it ends up being 1 in 20. Goofy, too high or too low. Fair enough? Ish? You guys buy that? So basically, an outlier, like I said, is an atypical data point. This is one way of measuring it. One way of measuring it. Now, what I want to do is I want to generate some non-bell-shaped data. Let's see if my height does it. Let's collect some more data. Let's collect my height. We don't have time to analyze it today. We might. So, shoes off. Hair down. Ponytail down. Let's not count the samurai knot. Okay. Guess my height. Nearest, what do you think? Inch?
Yeah.
Want to go inch? That probably makes more sense than half inch. Let's go height to the nearest inch. Well, guess. Can you stand up to measure? Okay. Well, you can't measure. You can stand up if you need to. Yeah, get a reference. Yeah, stand up, by all means.
I'm 5'6".
Put your hair down.
Yeah.
Glasses. Make sure you count for the glasses. There we go. Good, good, good. And if you just get, Haley, it's totally fine to just guess. Just guess. It's totally fine. Stand still. It's very hard for an Italian to stand still. I was talking at the conference, and my past department chair, Charlie Navigator, walked by. I'm Italian, so I'm doing this. So put your hands in your pockets and have that conversation. I'm like, I can't. And I literally couldn't. I tried. And the pockets started talking. They just can't do it. Italians can't stand still. I can't get their hands still. You guys got some guesses? Good. All right, let's come over here. Let's leave this up here for now. We'll slide this over here. Let's do, yes, my height. I said that kind of German. Okay, X equals height guesses in inches. And then we'll do frequency counts. All right, so let's hear some height guesses. 5 what?
5'11".
5'11"? Anybody below 5'11"? We got any, what do you got, Liz?
5'8".
5'8"? We got a 5'8", we got a 5, we got a Lena.
Yeah, I'm 5'8".
You're 5'8", anybody below 5'8"? So we got some 5'8", we got a 5'11". Any 6 foot evens? 6 foot evens? Yeah, any 6'1"s? 6'1"s? 6'2"s? 6'1"s the highest? Beautiful, beautiful. So let's break this down in inches. Oh wait, crap, I gotta do inches. 68 inches would be 5'8". 69 inches would be 5'9", 5'10", 5'11", 5'12", which would, I guess, be 6. March 82nd, otherwise known as May 10th. 73 would be 6'1", and I think 6'1" was the highest, right? We got some 6'1"s. Good, good, good. All right, fantastic, fantastic. Let me get my samurai knife back up. This is driving me crazy. How many 5'8"s do we have? We had Elena and Liz. We got 2 5'8"s. Beautiful. 69s. Any 5'9"s? 5'9"s in there? No 5'9"s? Okay. So we got 2 here. We got 0 here. 70. This is 5'10", right? 5'10"s? 5'10"s? No 5'10"s. Excellent. 5'11"s. 5'11"s. 1, 2, 3, 4, 5, 6, 7 on 5'11". Excellent. 6 foot. 6 foot. We got 1, 2, 3. 3 6 foots. And we had some 6'1"s. A couple 6'1"s. Is that right? We got 2 there. We got 3 6'1"s. Awesome. Fan-freaking-tastic data. Give me some summary stats, friends. Give me a graph. Give me a box plot. Give me a histogram. Give me summary stats. Give me the whole shebang.
Oh, yeah.
Yeah, that's what I'm saying. We ignored the quartiles over here. Let's get the quartiles up this time, too, for practice. We got the average and standard deviation. I was very excited about that. Let's get the quartiles up for this one as well. So I'll make a little laundry list for you. Some stuff to chit-chat about. We'll get an average with its standard deviation, get the median. What the hell? We got a mode. The mode's 71 inches. Let's get the Q1 as the median and the Q3 all together. I'm going to play 2. I'm going to put this right here. Gesundheit. Go right on top of the other data if it's okay with you guys. Say that again? Oh, okay. I'm telling you, it always is. It always is. It's always good. Always good.
Another exciting day in stats.
I'm telling you. Aren't they all? Oh, wow, that's freaking cool. That is wickedly cool. I gotta play. I love that box plot. I'm getting really happy with that box plot. I'm not gonna lie to you. Oh, look at that thing. Let's get it a little prettier. So let's go window. Xscale's already set at 1, so I'm gonna leave that alone. I'm gonna bump that max up to maybe 12. Get it off, yes. Okay, I'm gonna erase some bar. No, that's how I'm feeling, Jordan. It's mine. I'm not alive. I'm getting excited. How would you describe that?
Awesome.
Cool.
But besides awesome, they're definitely awesome. Would you call it a bell curve?
No.
I'm going to have a harder time calling that a bell curve. But I say a harder time. Look at the box plot. What's up with the box plot? What's missing? Right, there's either a quartile or a median missing. But it's not that it's missing. Give me some summary stats, friends. Give me some summary stats. We know what the modal guess is. Is the average guess like 70?
71.
Oh, it is 71. These two didn't pull it down low enough. So 71, it rounds to 71 inches? Beautiful. What's the standard deviation round to? 1.7 or 1.5? Let's just call it 1.5. As to not over or underestimate it. Okay, give me some quartiles and medians.
Q1,
71 inches for Q1. Median,
71.
Q3.
72.
There you go. Is the median missing from that graph?
It's just like
It's in there on top of Q1. Press trace. If you have your graph, press trace. Okay? Press trace. Now you can scooch. You can scooch on your histogram, which is great. Although this histogram isn't the most interesting to scooch on because basically it's a dot plot. Jump up to the box plot and scroll through. So your min value is 68. Your min value is 68. Your Q1 is 71. When you try to scooch again, it stays right where it is because basically what that tells us is what?
median 71.
The median is 71, the quartile is 71. That means this class is so small, this often happens in small classes. There's so few of you, 25% of you guessed between 71 and 71, which means more than 25% of the class guessed 71. Essentially, what that's talking about. And you can tell, you can see what's going on. There's a total of 15 data points, or ish, and half of you basically said that. So that's more than 25%. It's almost half of you said that. So that sometimes this happens with small, like I said, small data sets or amazingly tight data sets, or amazingly tightly controlled data sets. Cool?
So how tall are you?
How tall am I? I'm 5'11 and a half on average. 5'11 and a half on average. You guys are damn good. You got my weight damn good. You got my height damn good. 71 inches.
You said it before in the class.
Did I say that at some point?
You were talking about mother and father's.
Son of a bitch, I did! That's right, the mid-parental height. Son of a bitch, the guys asked a great question. You said, is there some other way of measuring? And I said mid-parental height. Son of a bitch, I said I was 5'11 and a half. Damn it!
I didn't remember.
Coloring the data.
That's why when you said guess, I was like,
I don't have to guess, you told me. Did you guess? Did you put down 72 though, Armando?
Wow.
Ah, you should have, because it rounds to 72, doesn't it?
You're right.
That's okay, but you're the man. You're the man.
Thank you.
I'm usually taller in the morning, and I shrink as gravity wins. And I tend to stand like this a lot too, so I'm only, 5'2". Okay, that's enough for today. Don't lose that data set. Let me show you a trick. Let's keep that data set till next time, because I want to play with it. Where are the outliers? Are these outliers? Are these outliers down here?
No.
We don't know. I don't think we should use this idea, this bell-shaped idea, to measure them, because it's not bell-shaped, right? So let's come up with a new rule next time, the one that TI actually uses when it draws box plots.
So keep that data?
Yeah, and here's a clever way of keeping it, because I'm going to have you guys do some homework for next time. So you guys, I'm assuming, put this in L1 and L2, right? Let's put it in L5 and L6 and keep it. Chances are you never use L5 and L6. I'm guessing. So let me just throw this up there. So watch this. Wander over to L5. You see where my cursor is? It's up there on top of L5. And then type second 1. Make sure you're on top of L5 before you do this. Make sure your cursor is actually up there. And then when you press enter, it'll dump those values in L5. And then do the same thing for L6, but second 2. And chances are you won't clear those lists when you do your homework. You might clear L1 or L2, but you won't clear both of them. So just knock those guys down. Cool? Makes sense? Okay, so could you bring questions, not on outliers for Wednesday, but bring questions on measures of relative position? It's the next homework set. Measure relative position. So just as you're going down the homework set, it's the next one. Let's make sure those questions get answered on Wednesday. Coolio?
And bring coupons?
Yes, bring coupons with corrections. Yes, I would knock those out quickly. They won't take you too long to knock out. Good, on the hand. Very, very good. I think I posted a quiz too. It's optional, of course. You might choose to not do the quiz this week because you did the in-class quiz. I got a 10 on it. Remember that. This counts just like any other quiz.
Yay, let's do more though.
Well, we will. I've got a few. I've got at least 3 more, no, at least 4 more in the works. So we'll do, I like them too, for sure.